Hello world, Liu here, and let's run through every single operator that exists in Python, including the weirder ones that we don't usually use. If you're new here, my name is Liu. I'm a software engineer from Singapore, and I make stuff that younger me would have wanted to see. Now, back to the video. So first up on this list, we have the assignment operator, which is also the equal sign. So this is one of the most important operators in Python. And using the equal sign, we can assign a variable to a value. So let's say x is equals to 5. So in this case, x will be the variable and 5 will be the value. Next we have, let's say y is equals to apple. So here y is the variable and apple is the value. So we assign y to apple. And if we print xy over here, we will get both of them. And here we have it. Next, we have the walrus operator, which is a variant of the assignment operator. So first, I'm going to write some code. So fruit is equals to apple, and if fruit is equals to apple, then I'm going to print, I don't know, apple pie. So if I run this code, this will work. However, using the walrus operator, we can actually shorten this into one line of code. So what's happening is that we want to assign fruit is equals to apple over here. So let's put a bracket and walrus operator apple. So let's get rid of this. So let's run this again and we should get the same result. So here, this expression does two things. So firstly, it assigns the variable fruit to the string apple, and afterwards it returns apple itself. So that's why if apple is equals to apple, we print apple pie. And next we have our numerical operators. So first we have the addition operator. So let's say we print 5 plus 10, and here we are just going to get 15. This also works for strings. So let's say apple plus pie, and we are going to get, apple pie. So next we have the subtraction operator. So this simply subtracts one number from another. So let's say 10 minus 3, and we are just simply going to get 7. Next we have the multiplication operator. So if we replace this with a multiplication, we are going to get 30. So note that this works with strings as well. So let's say apple, and I'm going to multiply it by 3. So what happens here is that we'll have 3 apples. And here we have it, apple, apple, apple. Next, we have our true division operator, which is this thing. So here, if we print 10 divided by 2, we'll just get 5. But in this case, we are going to get a float. So we are going to get 5.0. So similarly, if we divide 10 by 3, mathematically, we get 3.3333. So let's run this and we get 3.3333. So here we have 3.33333 all the way until 5. So this is just floating point inaccuracy, so just ignore it. And next we have floor division. So it has 2 slashes. So similarly, I'm going to print 10 floor divided by 2 and 10 floor divided by 3. So what's happening here is that this will give us an integer. So if I run this, I'm going to get 5 and 3. Next, we have the modulo, which is this percentage over here. So if I print 10 modulo 3, what's happening is that we'll have 10 divided by 3, and we'll get the remainder when we divide 10 by 3. So the remainder happens to be 1. So if we run this, let's comment this first, and let's comment this first. So if we run this, we'll get 1. And next, let's say we have 17 modulo 5. So here, when we divide 17 by 5, we are going to get 3 with a remainder of 2. So here, we are going to get our remainder, which is 2. And finally, the last numerical operator, which is the exponentiation operator, which is these 2 stars over here. So what happens is that if I print 2 exponent to 2, we get 2 to the power of 2. And this is going to be 4. And similarly, if we have 2 to the power of 3 and 2 to the power of 4, we will get 4, 8, and 16. And next, we have our compound assignment operators, which are our numerical operators, but with an equal sign added behind. So let's first talk about the plus equals. So here I'm going to have x is equals to 10 and x plus equals to 3. So if I print x at this point, I'm going to get 13. So what's happening here is that this is the same as x is equals to x plus 3. So x is already 10, and 10 plus 3 is 13, and that's why we get 13. So one thing to note is that if I did not define x before this, if I remove this, I'm going to get an error because x is not defined at this point. So similarly, let's say x is equals to 10 and x minus equals to 7. So what's happening here is that x is equals to x minus 7, which means that we remove 7 from x and we are going to get 3. So similarly, if I multiply by 7, I'm going to get 70. And if I divide by 7, I'm going to get whatever 10 divided by 7 is, 1.4285 whatever. So if I floor divide by 7, I'm going to get 1, and so on. So once again, each of these compound assignment operators corresponds to one numerical operator, just with an additional equal sign added behind. And next up on the list, we have our comparison operators. So let's just say a is equals to 4, and we print a is equal to 4. So here one very important difference is that this is the assignment operator and it does not test for equality, meaning that here I am just assigning the variable a to 4. And over here, I'm testing if a is actually equals to 4. So if I run this, I'm going to get true. And if I change this to, let's say, 6, I'm going to get false. So next, we can switch out the double equals for the rest of the comparison operators. So here, exclamation mark equals means that it is not equals to. So this is just the opposite of our double equal sign over here. So a not equals to 6. This is true because a is 4. However, if we replace 6 with a 4, we are going to get false. And next, we have our more than. So here, if we run this, this is going to be false because 4 is not more than 4. However, if we replace this with a 3, this is going to be true. And next, if we add an equal sign, this means more than or equal to. So if I rerun this, this is still going to be true because it's 3. And if I replace this with a 4, this is still going to be true because 4 is more than or equals to 4. So similarly, this is the less than operator, and 4 is not less than 4, meaning that this will give us a false. However, if I add an equal sign, I'm checking whether a is less than or equals to 4. So this will be true. And next on our list, we have our logical operators. So here, let's assume that x and y are conditions. So here, x and y, and x or y. So here, for x and y, both x and y must be true for the entire expression to be true. And for our or, either x or y must be true for entire expression to be true. So let's say that for a student to get a prize, his score must be above 90 and his conduct must be excellent. So let's create a score, let's say 91, and conduct is equals to okay. So if score is more than 90 and conduct is equals to excellent, we print prize, and else we print no prize. So let's run this. And here we get no prize because conduct is not excellent. So in order for this entire statement to be true, both conditions, score is more than 90 and conduct is equal to excellent, must be true. So only if I do this, excellent, I will get prize. And if I change this back to okay, this is a false now and we will get no prize. However, if I change this to a or, and if I run this, we are going to get prize. And this is because for or, either one of these just needs to be true for the entire expression to be true. And here score is more than 90, and that's why, because this is true, the entire expression is true. So it doesn't matter what our conduct is. So conduct can be bad or whatever, and it'll still be price. So let's comment this out and let's talk about not. So here, the not operator will just reverse our Boolean value. So let's say not true, and let's print not false. So let's run this and we are going to get false and true. So not true is false, and not false is true. So that's it for not. And next, let's talk about the in and is keyword. So firstly, we have the in keyword, and we use it to check if something is inside some other collection. So let's say fruits is equals to apple, orange, pear. And let's print whether apple is in fruits. So here apple is actually in fruits, so we should get a true. So let's run this and let's check what happens. And here is true. However, if I put something like pineapple, which is not inside our fruits, we should get false. So let's comment this and let's talk about is. Let's say x is equals to 789 and y is equals to 789. So let's print x is y. So here, the is keyword is used to check if two variables refer to the same object. And in this case, we are creating two different lists even though they may contain the same numbers, which means that this will give us false. However, if I remove this and y is equals to x, so now they both point to the same list. So if I run this again, we'll get true. And next, let's talk about our bitwise operators. So these are our bitwise operators, and we don't usually use them in our Python code. So to understand these bitwise operators, we first need to know that binary numbers consist of only zeros and ones. So for example, the binary number 0 is going to be 0, 1 is going to be 1, 1, 0 is going to be 2, and 1, 1 is going to be 3, 1, 0, 0 is going to be 4, 1, 0, 1 is going to be 5, 1, 1, 0 is going to be 6, 1, 1, 1 is going to be 7, 1, 0, 0, 0 is going to be 8, and so on and so on. So these are our binary numbers, and this is the value of a binary number if we convert it into our normal numbers. So in Python, to represent a binary number, we use this syntax. So x is equals to, let's say, 0, b, and from this point, we add our binary number. So let's say 1000. So we should get 8. So if we print x, we should get 8. And here we have it. So let's say we have 111 instead, we should get 7. Oops. And here we have it, we have 7. So this is how we represent binary numbers in Python. So first, let's talk about the bitwise n. So a is equals to 0b, 11110000, and b is equals to 0b, 11001100. So I'm going to print a and b. So what happens is that we'll compare them bit by bit. And for the bitwise n, only bits where both are ones will become 1. So if I print this, I'm going to get 192. Okay, sorry, let's convert this to binary. And we are going to get 110000. So here, only the first two bits are 1 in both A and B. And that's why our resultant is going to be 1, 1, and everything else is 0. So this is the bitwise AND operator. And next, let's talk about the bitwise OR operator, which is this pipe thing over here. So here, the OR operator, similarly, will look through our numbers bit by bit, and for our resultant bit to be 1, either the bit in A or B needs to be 1. So here we're going to get 1, 1, 1, 1, 1, 1, 0, 0. And let's check. And here we have it, 1, 1, 1, 1, 1, 1, 0, 0. Next, let's talk about the exclusive OR, also known as the SOR operator, which is this. So I'm going to add it here. So here, if we use this bitwise SOR operator, our resultant bit will be a 1 if A and B are different. So this is 1, 1, but this is also 1, 1. So this will result in 0, 0. So this is 1, 1, and this is 0, 0. So this will result in 1. This is 0, 0, and this is 1, 1, and this will also result in 1. However, this is 0, 0, and this is 0, 0. So this will result in 0. So what happens is we'll get 0, 0, 1, 1, 1, 1, 0, 0. Because only in the middle 4 bits are A and B different. So if we run this, we will get 1, 1, 1, 1, 0, 0. So assume there's a 0, 0 in front, but then it's just removed because it's just 0. And next, let's talk about the left shift and right shift. So I'm going to remove one of this. So let's say 1, 1, 0, 0. And A left shift by 1. So if I run this, notice that there's an additional 0 here. So what's happening is that we'll shift all our bits leftward by 1 bit. However, if I left shift by 2, then we have 110000, and here we have it. So similarly, if I replace this with right shift, all our bits will shift to the right instead. So next we are gonna get 110, and here we have it. And if I right shift by 2, I'm gonna get 11. And next we have the bitwise NOT operator, which is this twirly thing over here. If I run this, I'm gonna get -13 and 12. So this is originally 12, and if I invert it, I'm going to +1, and then I'm going to negative the entire thing, and I'm gonna get -13. And next, let's talk about the compound bitwise assignment operators. So these are our bitwise operators, but with an additional equal sign added behind. So let's say x is equals to 0b1100, and y is equals to 0b1111. So here, x n equals to y. So if I do this kind of thing, what's happening is x is equals to x and y, much like our normal compound assignment operators. So if I print the binary of x, I'm gonna get, probably still x, yes, correct. So what's happening is, cause only in the first 2 bits is everything 1. So that's why we get back x. So once again, the n equals is the same as doing this, same as our compound assignment operators. So similarly, if we replace this with or equals, then let's replace the n with a or, and we will get 1111. And here we have it. Same story with exclusive or. So if there is an exclusive or, we must replace this with an exclusive or. So we are going to get 0011, and this is just going to be 11. Similarly, this is right shift. So we have this. So right shift by 1 and right shift by 1. So if we do this, we will get 110. So notice that 10 is missing. So let's get rid of y first. And similarly, if we do left shift instead, then we must replace this with left shift, and we will get an additional 0. And here we have it. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.